The sun looks like the same steady light every single day, but underneath that calm surface, it's running on a cycle, rising and falling in activity roughly every 11 years, and has been for as long as we've been counting. Sunspots are patches on the sun's surface where its magnetic field bunches up and becomes especially strong enough to suppress the normal flow of hot plasma rising from below. That interrupted flow leaves the area cooler than its surroundings, still thousands of degrees hot, but noticeably darker by comparison, which is why sunspots appear as dark blemishes on the sun's face. Some sunspots grow far larger than Earth itself. Astronomers have been counting sunspots since Galileo's era in the early 1600s, and that long record revealed something remarkable: the number of visible sunspots rises and falls in a repeating pattern, reaching a peak called solar maximum roughly every 11 years, then dropping to a quiet solar minimum before climbing again. During solar maximum, the sun can display dozens of sunspots at once. During minimum, it can go days or weeks with none at all. The cycle itself was first identified in 1843 by German astronomer Heinrich Schwab, who had actually been searching for a hypothetical planet inside Mercury's orbit, and instead stumbled on the sunspot pattern almost by accident, after 17 years of near-daily observations. The 11-year cycle is driven by the sun's magnetic field, which is generated by the churning motion of plasma deep inside it. Over the course of each cycle, that magnetic field actually flips entirely. The sun's north and south magnetic poles swap places, meaning the true full cycle, accounting for the field returning to its original orientation, takes about 22 years, not 11. Solar physicists still don't fully agree on every detail of what drives the precise timing. That magnetic nature was confirmed in 1908 by American astronomer George Ellery Hale, who detected the signature using something called the Zeeman effect, the same physics that lets scientists measure magnetic fields on stars far too distant to visit. More sunspots generally means more solar flares and coronal mass ejections, which is why solar maximum periods bring stronger auroras, more space weather disruptions to satellites and power grids, and closer monitoring by agencies tracking the sun. There have also been extended quiet periods, like the Maunder minimum in the late 1600s, when sunspots nearly vanished for decades, coinciding with unusually cold winters in parts of Europe, a reminder that the sun's rhythm reaches further than we usually notice. Subscribe for more rhythms hiding in the sky above us. Heartbeat.